Hello everyone, welcome back. This is Naidu from Techno Legal Forum. Yesterday we have discussed in depth about two important concepts, namely hashing and encryption. Those two are the critical and underlining technology that is used for protocols. See, if there is a good understanding of those concepts, the understanding of any protocol becomes much easier. If you didn't get the opportunity to watch this video, that video, uh, message me. I will share the link for that. Okay. Today we are going to discuss about protocols. Okay. A protocol is one is a set of rules, predetermined rules, pre-agreed rules that is executed between two entities. Okay, it can be a client machine and a server. We'll see that in depth. For today's session, we will only discuss two protocols, that is challenge authentication protocols, CHAP, and the same protocol which is implemented by Microsoft proprietary protocol, that is MS-CHAP version 2. Okay, so this will cover today's session. The next session we will be covering the remaining and very important protocols. These protocols what you see in current enterprise organizations. Okay, let's okay, remember yesterday we already covered point to point protocol, right? It is basically a link establishment between the entities, two entities which they want to communicate. It's just as simple as it. This is establishing of this link, client and server. A link is done through a protocol we call point to point protocol. This is a kind of a pathway. On this link will support authentication, that what we are studying now, authentication protocols, compression, encryption. Okay, so PPP is just a link. On top of that, the protocols will be used for authenticating, means identifying the client with the server. So various protocols that we are going to study today. And as I also mentioned, it will also support data encryption. Okay, compressed data can be sent over this link. Why we need to compress? Because the bandwidth of the link is always limited, the speed at which the data transfers. So large files, if you need to send multiple large files, the bandwidth will not be sufficient. In those cases, the files are compressed and they sent over the PPP link. Encryption we already studied. This also we studied yesterday. Password authentication protocol, wherein the password, username and password are sent over from the client to the server for the purpose of authentication in a plain text. Plain text means it is not encrypted, so there is a high possibility of that being captured by hackers, and it will be a problem because they can act on the behalf of the client and interact with the server will not able to know whether it is acting, it is responding to the client or the hacker. So this is the most insecure protocol, so no longer used from the cyber security point of view. So what we are going to study is today CHAP. Okay. Challenge Authentication Protocol. So basically, if you recollect, password is very important because breach of password is itself dangerous. What if I don't send the password to the server, which has to authenticate only on receiving the password, right? Otherwise, how the server will know? For example, this is the server, this is a client, and this is a server. You have a secret here, secret or a password. The same thing is stored in the server. If server has to know this is the client, it is interacting, it has to prove itself. Yes, suppose if this is a client 1, yes, I am client 1, please allow me to access. So this is basically authentication server. Once authentication, the access will go to the authorization and able to access the network. The first stage in, as we discussed, IAAA is the first stage of authentication. Identity of this has to be recognized with the server. So this will provide a password which is here. This password already should be available in the server database, and we also Active Directory. So username along with the password has to be authenticated by the server. Okay. Now the point is, why we are focusing on this password, because password is the one which will tell the client this is the client which the server will recognize. But there is always bigger issue for all the organization, because you are communicating over the untrusted network, right? So if the packets containing the password is flowing through this untrusted network, there is a possibility of getting captured, and it will be used as if a fake client can start communicating server. So this resolves a biggest challenge that we are seeing so far. What is that challenge is? What if I don't send the password itself? Right? What if I don't send the password, yet I will able to inform the server that I am the one whom I am claiming to be. So how that happens? Let me share you. Remember, this is where I spoke about the importance of hash. So as we know, client has a secret, or we can say password. Server has a copy of it, password or secret. Unless this supplies these credentials, username and password to the server, this will not allow you to connect to the or access this one. So instead of that, using hashing, okay, password is fed to a hashing algorithm. It will generate a unique hash. Hexadecimal hash. Okay. What this client does, it will send the hash only. It will not send the password, because password in is representation of password is exactly this unique hexadecimal character. One important feature of hashing technologies is one way. One way means, suppose you got a hash, you cannot convert into password. That is the unique technology, I can say. Even the hacker captures the hash, he can't retrieve or use that hash and get the password. Right, we'll go back there. The hashing technology, what I'm mentioning is message digest 5. Okay, now you understood the core point, but here in this diagram, let me explain what happens. First step, server will send some random number, or we can say challenge. Okay, let's say this is done. Why random? Because again, the fear of this getting captured, because random means first time you are authenticating, this is the number. Second time you are authenticating, this will change. That is why it is called random. So the hacker who captured the old challenge or random value will not able to act as if he is talking as a client. That is the very essence. That's why we say, that's why we have to use the random number. It's just like our OTP. Remember, in our banking transaction, once you do the transaction, or if you delay to give the OTP, next time when you generate a OTP, the OTP number is unique. Why is that? Because the old OTP which you have already generated, it should not be used to get authenticated. It's as the simple analogy we can think of. So one is random number gets generated by the server and it is sent to the client. Now client, see, it has sent a number. Client has to give its credential, means it has to say his name, and he is saying that this is the one which you have already in the database. So it is identification. So what it does, as we discussed, it, because we don't want to send the password, right? Password is, we don't want to share in the untrusted. So it creates a hash of it. There is nothing but this operation. What is this operation? It's not only converts the secret or the password, it also, whatever the challenge or the random number, it also, these together it takes and makes a hash of it. Let's say H1 takes the challenge which was sent or the random number which it has sent by the server and the password which it is having inside. It will take both of them and run a hashing algorithm, that is message digest 5. It's no longer been secure now, but for the understanding we'll it's a hashing technology. It generates a unique hexadecimal number. We for now we'll just say it's a H1. This will represent challenge or the random number plus secret. Okay. Now the question is, why did he use the challenge here? Why did the client use the challenge? Why can't he just send the secret? Because if the server wants to know the secret which it is receiving, it is not from someone else. It should be from the client, right? How it will recognize? Because it has earlier sent one random number. If this random number is part of the secret, then it is 100% sure the message is coming from this one, right? One is password secrecy, that is password is converted into hash. Another is it want to make sure that the response it is expecting is coming from the client that it intended to get. That's why it is along with the secret and hash, both are coming as a part of the response. So once it comes, that is where the actual work happens. So we already know that server has secret which is the client want to authenticate, right? And the random number what it sent, it is already know because it is the one which has sent to the client. It uses the same the one which is it's in database, that is the secret, and the random number what it sent, it generates the same MD5 operation, that is hashing. If these two are equal, the one what is sent, right, and it will generate one hash, let's say H2 secret, and this thing will generate H2, it will generate hash. H1 which was generated by the client, combining the challenge what it received from the server and the password what it has, is equal to same hash code, because the secret of this one is already was there before even actual communication happened, and the random number what it sent to the client server is already, both are equal, then it is 100% sure that the communication is coming from the right client, right? Therefore H1 is equal to H2 means you have identified the right client, so provide the access. If there is a mismatch in the H1 and H2, it is obvious there is something wrong, right? Then it's a failure. Server will reject the connection. Okay, so the concept of challenge is a random number. Random number, once again, because next authentication this will change, so that will in turn prevent from anyone capturing the challenge previously and using it as as a legitimate client. So that will prevent from the cyber attacks. Okay, very quickly, we know So CHAP has resolved some of the issues what we found in the previous earlier authentication protocol, that is password authentication protocol, where password and clear text was sent over the internet. So isn't it? Only hash is sent. Only hash is sent. So user cannot obtain the password from the sniffed traffic, that is capturing the packet. One big issue resolved. This is anyway normal, right? Client will have its secret. The same secret should have been stored in server, and that is how the verification happens. MD5 hash, as I said, now consider it's a weak because of the the improvements in the processor speeds, where even this hash can be see password what generate the password which is fed, it generates a unique hash. So by lot of guesses at the input, we will be able to produce the same hash. So that is now possible because of the speed at which the processors available in today's world can do that. So it's no longer considered no longer considered secure, so it's not used. So we are using SHA-256, which that's yesterday what we discussed. Okay. So random challenge or random number or nouns, these are all same terms. A new random challenge is always, new random number is always generated. Okay. So this will prevent reply attack. Reply attack is nothing but just as I mentioned, right? So if it is not random, if it's a fixed number, if the server is sending man in the middle attack, MIM or eavesdropper will capture this packet which contains a random number. Later he will communicate using the captured random, that is nothing but reply attack means a fake or a rogue system will use the captured if it is a captured fixed random fixed number, then use the number and say I am the client, right? So to prevent that, every time the server generates a random, the value will keep changing. So even if you capture the previous one while receiving, remember the client will combine this combine the secret plus random number, both it will convert into hash. If this random number is got changed, then at the server when the recalculation happens, then it will fail. Okay, that is the prevention of this prevents reply attacks. Old captured responses are useless. Now, as I mentioned, once the when the authentication happens and during the connection existence of session between these two, there also possibility of that entire session can be captured and the random number still will be valid. Even that might happen. So the server will keep changing the random number during the session. A single session itself, the server keep changing the random value to prevent anybody capturing this session and taking the packet. So even during session and re-authentication, both the places, a random challenge will prevent session hijacking. So what is the disadvantage here? Here we are seeing that, okay, let me show you that. Here client is trying to prove its identity to the server, right? I am user 1. How it is proving? By sending the hash of its password. So one way proof, but server is not proving, right? Server is not proving that I am the right server you are communicating, right? That is the disadvantage, which is fixed, which is resolved in the next protocol that we are going to study. No mutuals, only authentication. The client is identifying to the server. Okay, client identifying the server, but the client cannot verify server identity. What if the, okay, let me go and show you the text for that. It makes things easy. We know about, we already okay, let me use okay, we know what is reply attack, that is done, and why we are using random value, right? We also know that. This is what no mutual means. It's both server and client are not identifying each other. Only authentication, client is only authenticating to the to the server. What is the consequence? Suppose if you build a fake server, like fake VPN server, a fake Wi-Fi access point, or a fake radius servers. So we are talking about, this is a client which is trying to authenticate to the server. This server, suppose you replace with a rogue, means hackers have installed a fake server. The client will not able to know, because the rogue server can also send this challenge and everything, and it assumes that it is sending to the genuine server. So this is the problem for this protocol. This is resolved in S2. Okay, we'll pause here and we'll continue after a 15 minutes break. Okay, see you then. Bye.